एल्फ्रेड वेगनर ने 1914 में इस थ्योरी को प्रेजेंट किया जिसको आज हम प्लेट टेक्टोनिक थ्योरी कहते हैं और ये प्लेट टेक्टोनिक थ्योरी कॉन्टिनेंटल ड्रिफ्ट थ्योरी पे बेस करती थी. ही वाज एक्चुअली अ जर्मन साइंटिस्ट और मेट्रोलॉजिस्ट बट वो जो थ्योरी थी वो जर्मन लैंग्वेज में थी और उसको आफ्टर 15 ईयर ट्रांसलेट किया गया इंग्लिश लैंग्वेज में. So फिर पता चला कि this theory was actually existed and today we call it the tectonic plate theory. Now with the passage of time जैसे जैसे हम देख रहे हैं मॉडर्नाइजेशन का एरा आ चुका हुआ है और टेक्निकल इनोवेशन में से हम गुजर रहे हैं. सो इस दौर में जहाँ पर हमें सैटेलाइट ट्रांसमिशन डाटा अवेलेबल है उस बेस पे इस थ्योरी में बहुत चेंजेस आई हैं, रिमार्केबल चेंजेस आई हैं. और ये रिमार्केबल चेंजेस जो हैं फिजिकल ज्योग्राफी में एक माइलस्टोन का दर्जा रखती हैं. सो विद द पैसेज ऑफ टाइम वी हैव इवेलुएटेड सर्टेन थिंग्स विच आर वेरी इंपॉर्टेंट फॉर द मॉडर्न थ्योरीज इन फिजिकल ज्योग्राफी. Now in plate tectonics theory there are three major boundaries. And these are categorized into three areas. Number one is the convergent boundary, number two is the divergent boundary, and number three is the transform boundaries. As we have already discussed that, the two boundaries which are convergent and divergence are 94%, covers 94% of the total area of the Earth's surface. And the remaining area is covered with the transform boundaries. Now here we can see that some of the areas are under divergent when two plates move apart. So this is called the divergence of the tectonic plates. And number two is the convergent area where we can see the plates are moving toward each other, toward one another. So this is one of the area where we have the motion of the tectonic plates, and these have three categories: the oceanic to oceanic movement, the continent to continent movement, and the oceanic to continent movement. So in this convergent movement there are three movements which are exist over the Earth's surface in plate boundaries, and number three is the transform boundaries. So these are also one of the very important area where we have the movement of the tectonic plates. Now, mapping of the plate boundaries, the discovery of the sea floor spreading and movement of the direction and rate of movement of the plates has enabled scientists to recreate their history. There are much geological evidence to give clues to the position of the plates in the past. For instance, the distribution of the ancient mountains as the Caledonian Belt, which today has remnant on either side of the Atlantic, and unusual deposits and fossils, have helped to pin down past plate positions, suggesting that two continents were once joined. Mapping and drilling of the ocean floor beginning in the 1950s and 60s provided further evidence of the plate movement. The Earth's tectonic plates are known to be in constant motion, shifting by up to 15 centimeters each year. However, the mechanism that causes them to move has been hotly debatable. Some scientists have argued that organized convection cells in the mantle move the tectonic plates. The relatively cool lithospheric plate are underlain by mantle rock that is hot enough to flow, and this creates more rapid convective cells. At their upper margins, mantle convection cells are thought to act like converger belt, dragging along the overlaying plates. Other scientists discount this idea and argue that gravity pushes relatively glowing plates down and away from spreading ridges. Radio telescopes arrays are helping to provide data about the movement of the tectonic plates. that is accurate to a few millimeters. The two stations are located on separate tectonic plates, so the relative plate motions can be determined. There are three main types of boundaries between Earth's tectonic plates. Plate growth occurs at divergence boundaries along seafloor spreading ridges, while plate consumption occurs at convergent plates boundaries, which are marked by deep ocean trenches and subduction zones. Divergent and convergent zones form 80% of the plate boundaries, whereas the remaining consist of 20% are called as transform boundaries, where two plates slides part one another with no significant change in the size of either plates. Now here one thing is very important. When the two plates are moving away from each other, the magma, the hot molten material, moves upward and creates the landform which is today called the volcano. Now this actually feature is located at the center of the ocean floor and today is called the Mid-Oceanic Ridges. And we have the very beautiful example of this Mid-Oceanic Ridge is in Atlantic, and this is called the Mid-Atlantic Ridge. Now this is the map of the Mid-Atlantic Ridge. Here we can see a S shape, the volcanic chain, which start from the island of Iceland, and not only it exists in the northern part of the Atlantic Ocean, but it also in the southern part of the Atlantic Ocean. So this is the divergence boundary, is between the divergence boundary, the softer area apart each other, and then the hot molten material comes up and we have the formation of the volcanoes there. So these are actually the landform which are existed on the sea floor. Where plates move apart, they form divergence boundaries. An example of the divergence boundary is the Mid-Atlantic Ridge, which stretches beneath the ocean between the north and southern pole. Although it rises above sea level in Iceland, divergence boundaries are marked by slowly spreading rift valleys. As two plates move away from each other, the mantle rises and partially melt to form basaltic magma. When the molten basaltic erupts on the sea floor, it solidifies as it comes into contact with ocean water, forming oceanic crust, a process that is repeated, and new oceanic crust is created at divergence boundaries at a rate of a few centimeters a year, a process called sea floor spreading. When two plates are separating to each other, they are also converging in an area which are at the side of the plate boundaries. So those are the areas which are called the subduction zones. So every convergence is followed by a divergence, and every divergence is followed by a convergence. So this is one of the features of the divergence areas where we have the formation of the rift valleys. So the softer material is moved away from the center of the action place, and then you have the formation of the rift valley, which is in the form of steps, and the sides are actually covered with the higher plains. But then the magma comes up, and this the middle part of the rift valley is filled with lava, and we have the eruption of the hot molten material and form the lava rocks, and we can say here the volcanoes. This is one of the again feature of the divergence area where we have the grabens, the host. The graben is also called the rift valley, and here the two things are the main features of the divergence plate, or even the area where we have the faulted environment. So this kind of feature is formed in regions where we have the divergence as well as convergence areas. लिहाजा हम ये देख सकते हैं कि सतह ज़मीन के ऊपर जो इनिशियल लैंड फॉर्म्स बने हैं वो ज़्यादातर टेक्टोनिक پلیٹس کی ایکٹیویٹی کی وجہ سے بنے ہیں. اور جب ٹیکٹونک پلیٹ ایکٹیویٹی ہوتی ہے تو اس میں والکینک ایرپشن بھی ساتھ شامل ہے. سو ایوری ٹیکٹونک ایکٹیویٹی از فالوڈ بائی دا والکینک ایکٹیویٹیز.